Hey guys, so next we're going to look at an example that deals with a biconditional. Now the biconditional, the true rules, people often make mistakes with these rules. Okay, so in this example I'm going to try to show you how to use the biconditional rules properly, okay, or at least one of them. So definitely pay close attention and keep this in mind as you are working on proofs for the rest of the week. Biconditionals require a little bit of forward thinking, a little bit of extra attention. They're not really special or different, it's just for some reason I find that often students don't read the rule correctly, or they just don't pay attention to how the rule actually works. Okay, so just take your time, pay close attention to what happens here. So this is the argument we're working with. A, if and only if B, B, therefore A. So I'm going to go ahead and get started just by writing out our basic assumptions here. So taking these two premises and starting off the proof by assuming these two premises to be true. So line number 1, A, if and only if B. We're assuming that to be true. We're using the rule of assumption. Second step here, we're assuming B to be true, and so we use the rule of assumption for that. Now we go ahead and we get started on trying to figure out what our overall strategy is for this proof. So we're going to try and figure out how this conclusion is connected to these premises. So as before, there's two parts to figuring out that strategy, right? So first part, we want to identify the conclusion, identify what type of sentence it is. So in this case, our conclusion is A, and that's an atomic sentence. Second part of figuring out our strategy, we want to identify how this conclusion is embedded in the premises. So there were a couple different ways that we talked about that happening before, right? Your conclusion could be embedded as a whole, and that would tell you that you're using overall an elimination kind of strategy, or your conclusion could be embedded in parts. And that would tell you that overall you're using an introduction kind of strategy. And now I know we've only looked so far at examples where the conclusion is embedded as a whole, okay, but I just want to kind of repeat this a few different times in a few different ways so that you can start recognizing some patterns and you can get used to doing this. Okay, so again, repeat this process. We've got our conclusion A. It's an atomic statement, and we see that it's embedded in this first premise here, right? We look at our two premises, or you can look up here, and we see that it's embedded in this first premise. There it is. So it's embedded as a whole in that first premise. Now we want to figure out, we know it's going to be an elimination kind of strategy. We want to figure out specifically what kind of elimination. Well, this is where the foresight comes in with the biconditional. So if you take a look at your rules handout, or if you think back to the lecture videos or the book, you'll remember that the rules for biconditional, right, we've got two of them. Right now we're going to just think about biconditional elimination. Now the way that this rule works is it takes one sentence as input and it gives you a different kind of sentence as output. Now what do you input into this rule? Well, you input some biconditional. Let's say you've got the biconditional P double arrow Q. And what this rule allows you to do is it allows you to pull out either of the two conditionals that are hidden inside this biconditional. So it's called biconditional for a reason. Remember, it's a combination of two conditional sentences. Right? So using this rule on this biconditional here, it allows us to pull out, we could either pull out P arrow Q, okay, we could get that on a line by itself, or we could choose Q arrow P. So the reason I'm going into this is because you'll notice that double arrow elimination, it doesn't allow you to just take out Q or just take out P right away, right? You have to go through the step, you have to pull out a conditional sentence. So double arrow elimination gives you a conditional. It does not just give you one of the conditions on their own. So thinking about that here, remember, we're trying to get A, right? Our conclusion is A, we're trying to get A, and A is embedded in this biconditional. And we just looked at the rule, we just saw that double arrow elimination, so even though A is embedded in a double arrow sentence, we're not going to be able to just use double arrow elimination and right away get A on its own. Okay? If we use double arrow elimination, it's going to give us one of two conditionals. So in this case, if we use double arrow elimination on this sentence, if we use, so we start off with A double arrow B, and if we want to use the rule double arrow elimination to break something out of that, well, we're not going to be able to just break out A. If we tried to do that, that would be wrong. You would get points taken off, so don't do that. Okay? What you would have to do is pull out one of two conditionals. So you have a choice here. You have a choice between A arrow B or B arrow A. One of these is going to be more useful than the other. In this case, we're going to want to use B arrow A. Why is that? Well, our conclusion, the sentence we're trying to get on its own at the very end, is embedded in the consequent of this conditional here. And if you think back to your rules, if you look back at your handout, you'll see that we have a rule that lets us break out the consequent of conditional sentences. We don't have a rule that lets us break out the antecedent of a conditional. We don't have a rule that lets us do that. But we do have a rule that lets us break out the consequent of a conditional. Okay, and that rule is arrow elimination. So, how is this proof going to work? Well, essentially what we're going to do is, looking at this here, looking at our first premise, we're going to use double arrow elimination to break out a conditional that our conclusion is embedded in. We're going to choose the conditional where the conclusion is the consequent. And then, since now our conclusion is embedded in a conditional, we're going to use that. We're going to use arrow elimination, We're going to use arrow elimination to break out the conclusion here in the consequent. Okay. So, that whole spiel, essentially what I said, is whenever you're trying to break something out of a biconditional, you're probably going to be dealing with a two-step process. First, you're going to break one of the conditionals out here, and then you're going to use arrow elimination on that conditional. So remember, this whole discussion was so that we could identify our overall strategy. For this proof, since the last thing we're going to do is break A out of a conditional sentence, that's the last thing we're going to do, I'm going to say that for this proof, our overall strategy is arrow elimination. So this is our overall strategy. So what I'm going to do, I'm going to write that strategy up here so we can just keep it in mind. Our overall strategy, the very last step we're going to take in our proof is arrow elimination. So now, let's get started on our little proof map like we did before. So again, we're going to make a little proof map. We're going to chart out how we're going to connect the premises to the conclusion. Proof map. So with our strategy, we've identified the last step of our proof, what's going to happen down here somewhere. So I'm going to write that at the bottom of our diagram.